Today's video is on parent functions, and there are a lot of them, but we're only going to focus on a couple of them. Parent functions are the basic standard graph that for linear absolute value quadratic, so there's no numbers in there. It's the regular form of the graph. Linear looks like y equals x. That's a +1 slope crossing through the origin. The domain and range are both all real numbers, just like that. The absolute value, we're not going to talk about, by the way, the x-intercepts or the end behaviors or discontinuity. We're just looking at what the graph looks like and what the parent functions are. Absolute value, that basic one is y equals absolute value of x. It starts at the origin and goes up 1 over 1, up 1 over 1 in both the positive and negative directions, making a V shape. The domain is all real numbers, but the range starts at 0 and then it ends at infinity. And the quadratic parent function, try to see if you can guess it. It is y equals just x squared, making a parabola. Starts at the origin, and it goes up just like this, and it's symmetrical. Oops. Just like that. The domain is all real numbers, and the range starts at 0, and then it goes to infinity, so bracket parenthesis. Those are the main three that we're going to focus on. There are a few more. I'm just going to show you what the graph looks like and the shape and the domain and range, but we're not going to have really many problems to do with it. Cubic looks like y equals x cubed. If you made a table with x's and y values and you plugged in your inputs and outputs, you would get the following ordered pairs, kind of looking like this. And the shape of the graph looks like that type of squiggle. But it looks like it goes on and on forever in both directions, positive and negative. This is the cubic function. Again, point at 0, 0, point at 1, 1, negative 1, negative 1. It also has a point at 2, 8, because when we plug in 2, we get 8, and also negative 2, negative 8. Let's look at some more parent functions on the other side. Again, just basic stuff about these. The square root function is y equals the square root of x. This graph, if you wanted to know what it looked like, starts at the origin. You plug in 1, you get 1. If you plug in 4, you get 2, and so on, only going this way. So the domain only goes from 0 to infinity. The range also only goes from 0 up to infinity. The cube root parent function is just the regular cube root of x. This graph, plug in 0, you get 0. You plug in 1, you get 1. And then cube root, if you plug in 8, 1, 2, 3, 4, 5, 6, 7, 8, you will get 2. And the same thing going the other way. If you plug in -1, you get -1, and if you plug in -8, you get -2. So it's a squiggle going like this, where both the domain and range are all real numbers. It does go on and on forever down, just takes a while to get there. And it also goes on and on forever up, just takes a while to get there. Okay, let's do the reciprocal function and see what that one looks like. Again, I just want to show you what these graphs look like right now. Reciprocal function looks like y equals 1 over x. If you plug in 0, you can't divide by 0, so there's actually an asymptote at 0, meaning that there is no graph there. If you plug in 1, you get 1, and then so on. You keep plugging in numbers. it's going to look like this, where it touches that, and there's also another asymptote going horizontally, meaning that there is no number that you can plug in for x for this answer to equal 0. And then the graph also goes this way, like that. That's the standard reciprocal function. Thinking about the domain and range, the domain is all x's not equal to 0. And the same thing with the range. It's not x's, it's y's. It's all y's that are not 0 as well. Exponential function. I know there's a lot of graphs. We're getting through these. Looks like y equals a raised to the x power, where a can be any number. What that does, or let's say a can be any number. What that does is it grows the graph exponentially, just like that. I'm gonna, instead of a, I'm gonna write the letter E and try to introduce you just real quick to the letter E. E is 2.718 ... It's an irrational number. We won't have to focus on this. Again, I just want to show you what an exponential function looks like. And a logarithmic function looks like y equals the log of x. We'll talk more about logs later this year. But just a little intro. It looks like kind of like a flip to the exponential, where it goes through that point and up and then down forever that way. There's an asymptote right here. And then for exponential, there is an asymptote right here. It doesn't pass that line. Okay, we got a basics of all the parent functions, but again, we're focusing on linear, absolute value, and quadratic. About transformations, this is the important part of the parent function video. So let's start with a parent function of the absolute value function of x. That parent function, I'm going to put in black here, looks like this. See how I can write that? All right. There we go. That is the absolute value function parent function. It looks like y equals absolute value of x. But what we're going to do now is just put in numbers into different places in this function to see how the graph moves left, right, up, down. It may flip. It may get wider or skinnier. And we're going to see what each of those numbers do. Here's the guide to the right side. If we add something inside the parentheses to the x, so for example, if our graph now looks like y equals the absolute value of x plus 3, what that means is that we're going to move the whole graph, including this vertex right here, we're going to move it left 3, that much. If we had y equals the absolute value of x, let's say minus 3, that means we're going to move the whole graph right 3. So inside the parentheses, the number with the x and the absolute value, that moves the graph left or right. Plus sign means left. The minus sign will mean to the right. Next, if we had our absolute value graph, let's say absolute value of x, but then we add something on the outside, let's say plus 3, that's going to move the graph up 3. Whereas if we had y equals the absolute value of x, but then we subtracted to the parent function, let's say subtracted 3 on the outside, that's going to move down 3. So use these keys to see whether you're going to move left, right, up, or down for your graph. If your a value in front, if that's bigger than 1, if the absolute value of it's bigger than 1, so for example, let's write y equals 3 absolute value of x, or we can write y equals negative 3 absolute value of x. What that's going to do to the graph is going to make it wider by 3, or you can say compression is another word of a scale factor of 3. So instead of the graph being a normal V, it's going to be a little fatter. Next one, if the y is less than 1, or excuse me, if the a value in front's less than 1, so like 1/2 absolute value of x, or let's say negative 1/2 absolute value of x, that's going to make it skinnier or more narrow. Another word is stretch. And you're going to say by a scale factor of 1/2. Instead of the graph being the normal V shape, it's going to be skinnier like that. And lastly, reflections. If we have a negative in front of the absolute value sign, just like that, that's going to flip the graph. It's going to reflect it across the x-axis. So instead of the graph going up, it's going to flip pointing downward. So in tough problems, you can have an H, a K, an A, and a negative sign, meaning that the graph's going to move either left or right. It can move up or down, or it could be reflected. It could be skinny, stretch, wide, compress. Let's do one problem where we see a couple of those. For numbers 1 through 7, all you have to do is tell me whether it's going left, right, up, down, a combination of them. Is it flipped? So for number 1, it's inside the parenthesis. So we're talking about the H's, and it's plus. So that means it is moving left 2. So the graph starts here. And if you move left 2, the whole graph is going to move over left 2. So now your new graph is over there. Try answering the rest of 2, 3, 4, 5, 6, 7 for extra practice, telling me whether it moves left or right, up or down, stretch, compress, by what scale factor, and whether it's reflected. These are basic because there's only one transformation being done to the regular absolute value parent function graph. Later on, we will have multiple transformations. So let me know what questions you guys have, and have a good night.